All right, so thank you so much. Welcome back to our next video. And for today, let's continue with our topic with our graph, and that will be the Prim's algorithm already. So the next, let's define what is Prim's algorithm. When we say Prim's algorithm, that is a greedy algorithm that starts with an empty spanning tree. And of course, used to find a minimum spanning tree as well as the maximum spanning tree from the graph data structure. So a subset of edges that also includes every vertex of the graph such that the sum of the weights of the edges can be minimized or maximized. A collection of edges in a graph that connects all vertices with a minimum or maximum sum of edge weight. So our focus here, as long as that we wasn't able to put a cycle, and if we are doing with a minimum spanning tree with using the Prim's algorithm. So we make sure that we maximize step by step dapat si Prim's algorithm. So say for example, what will be the adjacent of A and which is minimum or it could be maximum. So it depends on that one. After you check the minimum, for example, it will be 4 and what will be the minimum for C and for A if there is minimum right there. We'll begin to check that later on. So the next one will be the algorithms that we can follow. First, we determine the arbitrary vertex as the starting vertex of the spanning tree. So suppose that we are starting at the vertex N. So it could be something like that. And after that, we find all edges that connect with three in the above steps with the new vertices from the edges found. And we have to select the minimum or maximum edge and add it to the tree. And if it does not form any cycle, so we repeat the second step until the minimum or maximum spanning tree is already formed. So as long as you're following that algorithm, you can perform the minimum or the maximum spanning tree already. Next, for that one, applications of Prim's algorithm can be applied in terms of network designing to make network cycle, can be used to lay down electrical wiring cables. So that is really useful in that certain thing as well. And there's a lot of applications that we can still definitely do. So first thing here, we will begin to do the minimum spanning tree using Prim's algorithm with our first example. I actually do have here two example for minimum spanning tree using Prim's algorithm. Now, our focus is minimum spanning tree. So first example, this one. So suppose that we do have that kind of example right there. So what will be our goal is to minimize that one. So since our arbitrary initial state, suppose that we are initializing using the A is our initial state. So from our A, we actually draw that in our step one already. Next step, we can check right here, is there any adjacent to A, which is minimum? So what is the minimum? Is it 10? Is it 8? Is it 4? So 4 is absolutely our, A to C is our next path that we can do. So we can make sure to do that. So that is 4. Afterwards, we can check if C to D, if it is minimum or A to B or A to D, it depends on you. So in that certain case, A to B is much more, um, much more minimum than 23 than 10. So we can choose that one. So 8 is already our structures right now for the third step, but 1 cannot be picked since that forms a cycle and repeat to itself, and loop is still is considered as a cycle, by the way, just to let you know. And then afterwards, about that, we also do have here then the fourth step. In our third step, we can check if in your what will be the maximum for example, for the C. It is 23 and it will form a cycle, and so we can reject that node. And for D to B, it is 7. A to B, that is 10. So now, by comparing that one, so we can choose D to B. So that is 7. So that is already, since you only do have four vertices and your four vertices was already found and you already performed the spanning tree or the minimum spanning tree of this graph. So therefore, we are also in our data in our algorithm that we need to also calculate the minimum spanning tree. So you just add up everything, 4 plus 7 plus 8. So that is equals to 19. So four vertices, we have four vertices, and our minimum spanning tree consists of three edges. That's how it works actually. Now, let's continue with the next example then. We also do have here a example, something like that. So it is somewhat hard as earlier compared to the first example that I've actually give. So suppose that in your first step is your A. So you can perform that in here. A to what will be the adjacent of A? That is C and that is D. So that is 12 and 5. So therefore we can choose 5. So that is A to D. Now, you can check right there. Well, for the adjacent of D, that is um 34. That is 4. And for A, that is 12. And for D, there is 13 and 34 and 4. So our minimum right there is 4, di ba? So you can choose that one. As long as it's connected class, because we are dealing with the connected, for the Prim's algorithm, we will step by step look for a possible path which is connected and does not conform a cycle. Now, here then we choose letter C, D to C, and that is 4. So that is in our third step. And you will also compare. So A to C, that is 12, and that can conform a cycle. So we just reject that. And C, the adjacent of C will be 22 for letter E, and will be 9 for letter F, and your D as well here. Since you have D, that is 13, and that is 34. So by comparing that one, we have 9, we have 22, we have 34, we have 13. So we can actually choose the 9 since that is minimum right now. So we can definitely go ahead and just copy as this. So you have already right now a 3, 4 vertices, I mean. Now let's continue to check then. Since we can reject this 12, and in your C, let's try to check first the C. 22 and 9 is already thick. And let's try to check in your F. So that is 15, that is 34, and that is 23. And your D, can check with the adjacent of D, that is 13. So by comparing with those things, that is 15, that is 22, that is 34, and that is 23 and 13. So the minimum right there will be 13, di ba? So in your fifth step, you can choose the 13. So 13 is now added, and you can now check since this is 5 and your graph, I mean, is actually consists of 6. So now we can check right there in your C what will be the adjacent. It will be 22, and 22 is we can compare later on. And for F we have 34, and we can definitely remove that since that will conform a cycle. And 23 is also maximum. Letter D is also 13, already picked. And 15 here for E, that is actually minimum. So we can actually choose for D to E, which is the 15. So if you can check right now, you already do have all of the vertices. So since you already do have all of the vertices, so there's no need to check everything since 23 is will form a cycle, and 22 can form a cycle, and here 34 can form a cycle, and 12 as well. So this will be your minimum spanning tree for using this Prim's algorithm. Now, your minimum spanning tree, you can add it up everything. 4 plus 5 plus 9 plus 13 plus 15, and that is equals to 46. So your minimum spanning tree of this one using the Prim's algorithm will be equals to 46. So that's actually how does it work for Prim's algorithm using the minimum spanning tree. So this is the end of our video, and the next video I will also share to you how about if you will be going to deal with the Prim's algorithm when it comes to maximum spanning tree. So see you there.